Hi, my name is Deniz Karagülle, and I'm a Senior R&D Product Engineer at Esri. I'll be starting off the workshop and will hand things off to my colleague, Paul Dodd, who is a Senior Product Engineer for the Livefeeds, and he will drill deeper into the workflows of Livefeeds. Also joining us is Gonzalo Espinoza, who is a Senior Product Engineer who will cover Livefeed layers for disaster response maps. All of us will join you for questions and answers after the presentation. So please enter your questions and comments in the chat window at any time, and we will pick them up later. Let's begin. Livefeeds are dynamic layers in ArcGIS Living Atlas of the World that shows the most recent information from authoritative sources. They are updated every minute, every week, every month, depending on data that is coming from the source. We're adding the created data to each of our Livefeed services as the providers make it available. Therefore, this is not telemetry data. Many are available to the public, not just ArcGIS subscribers. Many are already available within consumer-facing applications such as Drought Monitor. These Livefeeds are incredibly important. As our world becomes more and more complex, we need current information. This current information helps us respond to these complexities, helps us understand how we are responding to events and managing our activities. Timely information helps us live in a sustainable and resilient way. Recently, these services were opened up to better support the emergency management and disaster response communities, as well as benefiting the public. We use Livefeeds mostly for emergency management. However, you can use in your workflows, in your analysis, and they could be applied to any kind of discipline. Let's do a brief overview of what we have as Livefeeds. We added many important global Livefeed services to the Living Atlas in the past year. Global demographic data updated quarterly. Political boundaries are a good example because as soon as they occur, people want them. We're always adding new global Livefeeds and improve the existing datasets. So if you would like to contribute, please contact us. For example, this year, Canada and England contributed their stream gauges data. So we incorporated these countries' stream gauges live data into our global Livefeeds stream gauges dataset. Any country that produces this kind of information can use the Livefeeds, the methodology, to share their content. US-specific domain is mainly for emergency management and disaster response communities, as well as benefiting the public. We pull a lot of information from National Weather Service that's made freely available for the US. We definitely have a lot of content there. Their weather watch warnings got updated every couple minutes. The Living Atlas team worked closely with Esri's disaster response team and customers to improve the appearance, performance, scalability, and reliability, especially when high-demand events occur, like a landfalling hurricane or massive wildfires. We currently have 26 Esri-hosted feature layers, Livefeeds, and in total 59 maps, layers, apps in the ArcGIS Living Atlas of the world. One of the things that we learned about Livefeeds is they are very popular. Our most used Livefeed service that we have this year is the US current wildfires that you're seeing at the bottom. This service leverages the authoritative source of integrated reporting of wildland fire information, location database, along with the polygon parameters from the National Interagency Fire Center. It updates itself every 15 minutes. This layer has been viewed over 82 million times in the past year and provided more than 3 billion maps for those users. This is how you can access the Livefeeds contents that is available to the public from the Living Atlas without using any credits. The easiest way to access the Livefeeds is through Living Atlas of the World website. To go there, I'm going to open up my internet web browser, and then I'll type livingatlas.arcgis.com. We land to ArcGIS Living Atlas of the World website. And from the search box, I'm going to type Livefeeds. And now we're seeing all the Livefeeds hosted feature services within the ArcGIS Living Atlas of the World. This is the easiest way that you can access without even signing it. The other way that we can also look at Livefeed's datasets is through the group. So in order to access to the group, we can click on one of these items, and then here I'll select the groups. And when I click on the Livefeeds, and you will see the Livefeeds group. Livefeeds can be used in two ways. One of them is ready-to-use spatial data, which is what you just saw in the Living Atlas, so that you can use it in ArcGIS Pro and other environments such as Python notebooks. The other way is consumer applications. To give you a quick example of how they can be used in consumer applications, here you're looking at the indicators of the Planet consumer application. This is a good example of how we can leverage the global Livefeeds information. In this application, we have 18 different topics represented by 18 geocards. Each geocard accesses a Livefeed hosted feature service, runs summary statistics, and displays the result to better understand each issue and learn how to integrate timely data into decision-making towards building a sustainable planet. Livefeed layers are kept up to date by Livefeed routines that automate the process of overriding the information in near real time without service interruptions. What I mean is, Livefeed is a process. What we use in terms of Livefeed process is a code written in Python using Python API to pull data from the authoritative government source and process that into some meaningful information and deploy that onto ArcGIS Online as a hosted feature service. This methodology does not only pull the data from the source website, but also checks the quality of the data and process the data to be more meaningful on the display. Let's say you have your own real-time datasets and you would like to process this dataset into real-time feed. You can utilize our methodology to do that. This methodology monitors data source changes. When changes occur, process them, publish them as hosted feature service. Those changes are automatically ingested to web maps. Livefeeds are continuously updated, monitored, and maintained, and include both United States and global coverage, so our users can consume the most recent data. Speaking of monitoring and maintenance, we just deployed a status dashboard for Livefeeds for the users conference. Besides the current service status, it shows last update time, usage and usage trends, and feature counts and requests. It will be an important tool for customers, improving transparency and confidence in these critical feeds. Now, Paul is going to describe workflows for Livefeeds. Back to you, Paul.
Thank you, Denise. Hello, everyone. This is Paul Dodd, and we'll spend a little time talking about update workflows, things that you can do to maintain your data, different techniques. So first thing that comes to mind is the actual data details. This is something about the properties and information about the data, not necessarily the data itself. And the first topic comes up here is data ownership. Do you own this piece of data that you're maintaining? Is it something you're pulling from a third party where you have no control over the schema, the format, design, right? So this is something you might want to think about. Maybe you need to actually pull this data down locally, maintain your own copy of it before you create the service. That way you can maintain and control the schema changes when you're ready to post them. Next thing that comes to mind is the update frequency. How often do you change this data? Is it annual update or quarterly, something that changes once a day or hour, even minute to minute, so they can change or control how you decisions on how you update your data set. Row replacement. If you're dealing with a handful of record changes every time you make an update, or is this something where you're likely to replace the entire data set, all rows, every single time you make an update? Think about unique keys. Is this data set, does it have a field that contains a unique identifier that you can leverage to update the service data from? And then look at the outage tolerance of what your users can actually comfortably accept if you need to actually make a change or an update to that service. How long can it be down? Another thing that comes to mind is think about the purpose of this data, of the service itself. Is this something that has a historical collection, something where you're maintaining additions over time, you're just growing this data set? Is it something that you're only maintaining the current values for sensors? Or is this something where you have a rolling window, where you're maintaining the last 3 days or 7 days of information, and that window just rolls forward? And the last thing here that we're thinking about is the size. Is this data that you're dealing with, is it fairly small, something that's lightweight, easy to manipulate, easy to update? Or is this a large data set? Is this something that has millions or billions of rows, and it takes hours or even days sometimes to update the service? So these are all considerations to keep in mind when you're selecting or deciding on an update workflow. So the next step here is thinking about your published source. What is the source of the service that you're creating? Is this coming from flat files like CSV or shape files, JSON? Or is it something a little more intelligent where you have more control, like the file GeoDatabase, or you're publishing from a service definition created by Desktop or Pro? There are limitations if you're selecting a simple file format like CSV to publish. You do have limitations. It's fairly easy to publish, but you're going to be limited in your design options. You may not be able to change the schema once you publish the service. The functionality is relatively low or basic when you start with, but then you can of course modify the service after the fact. So on that same topic, if we look more in depth at the flat file systems or formats like CSV, Excel, JSON, again, easy to publish, they're widely used. They only support a single layer or table within that service. And then, of course, you have the schema restrictions. Does it support the aliases, types, field types, the sizes of the fields? No indexing that you can start with. You have to add that in later. If you republish, it doesn't change the schema once you do it. And, of course, there's no symbology. If we look at shapefiles, of course, you can republish, and the change is actually embedded in the shapefile itself, so that field properties can be modified during the republishing side, so it does allow manipulation of the service. Field name lengths is an issue, of course, with shapefiles. I believe it's 8-character field names. If we look at file GeoDatabases, now you start getting into the ability of creating multiple layers within your service. So you can host one service and have multiple layers to work with and render from. It does support domains. And of course, when you republish, the schema does or can change if you so choose. Next thing is looking at using the service definitions created from Pro and Desktop. In this case, you definitely have the ability to publish a service that includes symbology. You can enable time series on these services. Of course, republishing can change the schema. And then, of course, there's properties and things you can take advantage of within the service definition. Next thing I want to look at is when you're doing these update workflows, you want to look at what your risk versus effort. How much does it take to do this kind of update workflow, and what is the risk to the service, to the end user? So if we look at the low effort side, you're dealing with appending data, in this case just adding new rows to a table or service. You can do things like dropping rows and replacing or adding after you've dropped it. So you're using the truncate and append. So you're eliminating all rows and adding new ones in. So that's essentially refreshing that service. Then also too is another mechanism for updating it, which is republishing. So you're using the publish with overwrite, which would replace the entire service and the data, but keep the item details intact. A more medium effort, you're looking at using update or insert with unique keys. So this would be the append with Upsert. You can actually control updating existing features or adding new ones. Of course, if you need to remove older content or now stale records, you have to use a delete action on the service to remove that, because the append won't support deletion of rows yet. And of course, another mechanism for the medium effort is updating with views. So if you have a view on a service, you can actually work with multiple services and be able to update the service. And of course, the higher effort workflow stems around managing the rows themselves in the service. So now you're updating rows that you actually have to maintain. Well, what row is that? What's the ID? I want you to replace the fields within that row with this new update data that I'm providing. So you need a little more effort, a little more work involved in your update routine to manage that data. So it can be a little more complex, but you can see how the different workflows, looking here, how you have more effort or less effort depending on what that workflow can provide, and then the risk to the service. So if you're doing a publish with overwrite, you have a high risk that you could, number one, you're going to stop the access to that service because you're overwriting it. But then if something happens catastrophically, you can have an issue with the service and have to recreate it. So there's points at which you'll want to weigh that risk and the benefits of updating it with that workflow. So getting more into depth into the different workflows, if we look at just the append, we can actually insert rows into the existing service, just adding on to the end. It's pretty straightforward. And you can use the service or layer REST endpoint to the append REST endpoint to accomplish that. If we look at the truncate of how you remove rows, delete is a way of removing a row or a series of rows, but there's a lot of overhead involved in the database to actually delete records. So if you want to clear out all rows, the simplest way and fastest way is to use the truncate. This is an administrative operation on the service layer itself. So if you issue the truncate, it will immediately drop all rows, and it does it very quickly. It resets the object ID back to 1, so you start with essentially adding new rows starting with object ID 1. So it's as if you reloaded that layer and started over. So the combination here would be using truncate and append. So you clear out the rows and then you append the data back to it, for the updates. Pretty low risk when you get into republishing. Next workflow is the append with Upsert. This one's a little bit more involved. You're of course updating existing rows or inserting new. Include a unique key. It could be the global ID, object ID, or a unique identifier attribute field that you've defined and specified here. But still, the manual removal of old data is still up to you. You have to do the delete or the truncate to do that kind of removal. And one of the service examples that we have is the NOAA's warning watch advisories in the live feeds. And of course, we're doing an update using the UID field, which is the event identifier or the ancillary geometries like the state and the county and all that. So as those change over time, it can update them. We remove the unchanged rows with that using the delete feature endpoint on the REST layer itself. Makes it much easier to work with. The next workflow, of course, is apply edits. This has been around for some time with the services, so this is a bit more involved. Of course, you're having to manage and maintain the update process. So you're doing, insert these rows, update these rows, delete these rows. So you're having to be very specific about what you're changing and what you're adding in. This is a batch environment, so when you submit this, you're submitting 1,000 rows or 1,000 changes, if you will, at a time. It's very piecemeal. It can be chatty because you're iterating through the data, or you're iterating through your updates. So you could make several, tens or hundreds of requests to make that complete, and you're passing basically raw JSON data back and forth, small quantity of records. And as an example, we have a Waze service that we have that is maintained in this fashion. So we use the service layer deletes to remove expired content, and then we use the add update delete to synchronize with a local cache. Next one is append and delete. This is an interesting combination. Of course, you're using the standard append to add on new data, but then you're implementing a delete action, so you can strip off the older content. Something that's not relevant, you strip it out. In this case, you could use some kind of an update cycle. This is really up to you and how your workflow would make sense, and how it would make sense to use the data. You can delete the stale cycles. So if you're have a progression of your cycle, or in this case, I think ours is using the actual period date. So we're updating by period, week by week. So we can actually target a specific week and remove it, and then replace it in this workflow. But the views, if you create a view from the service, you can actually use a definition query in the view and select or specify the cycle you want to display. So you can actually have, last week's cycle is current. You import or append this week's cycle, but yet since you have a definition query on the view, the users can't see it yet. But then you modify the view and then tell it to use this week's cycle as the current. So you can manipulate the presentation of the data while still being able to load and manage it without having to prematurely expose it. In this case, we have with the drought intensity service, the current drought is actually a filter on the historical drought intensity layer, and we're filtering it by maximum period. So all you see is the most recent period presented. So another workflow, publish with overwrite. This is essentially you're publishing a service. It could be a brand new service that you've published, right? But in this case, we want to publish the same service but overwrite the contents. So this maintains your item ID. You don't lose that reference to the item. It replaces all the service data. But the negative effect of this is that when you do the publish, you're actually making that service inaccessible, because you're deleting it and recreating it. So that will interrupt a user that wants to use the service. So if the data is relatively small and lightweight, it's not a big ordeal. It doesn't take long to do the overwrite. It's fairly fast. So you might see a 20-second, 30-second, a minute outage, by just replacing that data. So it may not impact your end users that much, especially if you're using CDN as a public service. It's backed by the CDN, so a lot of those interruptions will not even be noticed. So it's fairly lightweight. But if you're dealing with large data, millions of records, this outage could happen, and it could take half an hour. It depends on the size and complexity of the data, but it could render that service inaccessible for quite some time. So when we publish services, we like to use views to present the data. That keeps the service private, and the view is then public. And you can manipulate and control that view, or have multiple views if you want, that present data in certain ways. You might have a case where you have a historical data set, but you only want to present the most recent information. So you can have a service that maintains all of the historical data, but then the view is restricted or set to present only the current data. So it's one way of doing it. But in this case, we can leverage those views to do more. We can actually use what we call a layer swap. And the layer swap is a technique that we use to maintain the service, and we have a case where we have a service that's published. We want to replace the content, but we don't want to disrupt what the users are doing with it. We don't want to stop them from accessing it. So what we have is two identical services, both of them private. The view is public, and it accesses whatever the live or current service is. So you end up with an active service, and then we have an update or target service, an idle service that isn't being used at the moment. And so when we do the replacement of the data, we actually update the target, the idle service. Then we actually implement the layer swap. And so what we're doing is we're altering the view itself and pointing it to the services or layers in the newly updated idle service that we worked on. So once that's done, now your view is looking at a whole different service, and it only takes seconds to complete the swap. So essentially you can do an update, you can swap the view, and then you can repeat. So if you have a service that updates daily or hourly, then it can be handled in an automated way where you're always updating that target or inactive service behind the scenes, and then swapping the view to point to that once it's ready. So what we oftentimes use this for is the ability to stage large data. So you might have a large data set that you need to update and maintain, but again, you don't want to disable end users. You don't want to have to schedule a large update cycle in the middle of the night, or on the weekend. You're spending a lot of time and effort to maintain that or to update that data, and you're under pressure to make sure it gets completed. So it can be a lot of work just to get that new service updated. And if something goes wrong, you have to start over again. And now you have a service that is no longer functioning because it failed to do the update, right? So in this case, you can use this methodology to update that inactive service and then perform QA on it, make sure that your quality assurance is in place and everything is what it should be. You can even test against that service, make sure it has everything you need and want. And then once you're satisfied with that process and the quality of that data, then you can elect to swap the layers. And now the public can see the new content based off your view that you've shared publicly, and it doesn't interrupt what they're doing or what they have access to at that time. So we have a script that we use for this process, and it's called the wOverwrite feature service script, and it has this workflow featured within it. So look for that. Let's move on to different interfaces, things that you would use to maintain and update your services. So if we're looking at hosted feature services, and of course this could be in online or this could be within your enterprise portal, you could have hosted services. And in that case, you could use the service REST API actually to manipulate rows in the service to add or edit or delete data. And of course, if you're the owner of that service, it doesn't require any editing capabilities to be turned on. And the other aspect is using the admin REST endpoint. And in this case, you can use as the admin or the owner, and you can manipulate the service properties. You can also do the layer truncate, to remove rows. And of course, you can use the ArcGIS Python API. This is a very full-featured API that allows you to manipulate items and services and everything you can imagine within the online or portal environment. So it's very handy. We use that quite often. And on the enterprise side, if we look at the enterprise services, now this is dealing with ArcSDE based data sources, so a database driven service. In these, you can of course use the same service REST API, the admin API, to manipulate data and the service and control that fully. You can use the Python API to manipulate that service content. Even the ArcPy can be used with a database connection. So if you need to manipulate that data directly. But don't forget that you also have the ability to use the database SQL commands. So you can use SQL to manipulate and modify data, or even do import of flat data, or load things quickly. We've done that with the National Water Model in the past. It's worked really well. Then the other part is, don't forget you have spatial views available to you in the enterprise side. So if you need to manipulate by truncation of data, you can't always do that if the service is actually publicly accessible, because those layers in the database are being accessed by the service. But if you create a spatial view from those layers and the service uses the view, then you don't have an issue with locking on your GeoDatabase layers within that ArcSD environment. So you can easily truncate a service and load new data without impacting or having to stop the service. That's kind of nice. So another aspect, if we look at the file GeoDatabase side of things, we start to peel back the ability to work with the Livefeed methodology, the traditional architecture that we came up with for maintaining services and data. This is where you're managing a file GeoDatabase, a work database that's offline, not being used by the service. You're controlling the record level maintenance, reorganizing whatever you have to do within that feed routine that you're creating. The important side here is that you're doing consistent update processes. It's the metadata of the file GeoDatabase that's important here. So you're creating a file GeoDatabase, you're creating your feature classes, you're creating your tables, and you do things in the same process flow, the same order every time you do it. That way you're not manipulating or changing the structure of the file GeoDatabase from one update cycle to the next. And once you've populated your data, then you can actually leverage the ability to overwrite the file GeoDatabase files. And for what we've done in the past is, of course, using Python's shutil, copy utility that can actually copy file to file, and it overwrites the content of the file, not the file itself. So even if you have a service that is accessing that file GeoDatabase and it has a file open, the copy routine can still overwrite the data in that file, and it doesn't disrupt the service. So you don't have to stop the service to update your data set. So that was our original design, and it's still working today. More on Livefeed methodologies, of course, our big goals here are to minimize downtime. We're working towards automated processing, different workflows. You want to be able to handle minute-to-minute updates or even periodic updates, so whatever your needs are. And we really want to provide flexible workflows for most any data that you have that you want to publish and work with. So different resources. I mentioned the Overwrite feature service tool, so we get a link to that. And we have the ArcGIS online group for live feeds. I've given a link to that as well. So that's all I have, and I'd like to pass it over to Gonzalo. He'll get into more of the usage of the live feed services and what and where you can work with them. So thank you very much. Gonzalo?
Thank you, Paul. Let's now talk about how live feeds are used in disaster response maps. There isn't a better example of how a live feed can be used to keep a layer updated than the one set up for the COVID-19 dashboard of Johns Hopkins University. The live feeds workflow that Paul described in the previous section was implemented to automatically retrieve the latest data on COVID-19 cases and to update a feature service in ArcGIS Online. Even before COVID-19 was declared a pandemic, the live feed methodology allowed millions of users to track the latest record of COVID-19 cases with seamless updates in a single site. You can create your own live feeds to update layers in ArcGIS Online, or you can use existing live feed layers in ArcGIS Living Atlas for a variety of applications, such as disaster response. In this section, I'll show you how live feeds drive disaster response maps, how hosted views can improve usage, and how live feed layers are included in maps, apps, and dashboards. A live feed is an automated process for updating layers in ArcGIS Online. We use live feed layers for natural disasters, such as earthquakes, wildfires, or floods. A Livefeed routine accesses information from a data source in near real time to update a future service. The Livefeed methodology is used to automate the updates of natural disaster layers in near real time, but it can also be used for layers updated routinely every month or every year. Once a Livefeed routine is created and configured, it will check the data source for changes and update a feature service when new information is available. A hosted view or multiple hosted views can be created from a feature service. The Livefeed views can be included in any web map that can be shared to a wide community of users through Living Atlas. An example of a disaster response map is the US Wildfire Reports app. This map shows layers from 3 different sources: locations from the integrated reporting of wildfire information, perimeters from the National Interagency Fire Center, and thermal hotspots from remote sensing. Each layer is updated by its custom Livefeed routine at their own frequency, so local communities are kept informed about the latest wildfire data in near real time. Another example of a disaster response map shows the forecast of river discharge from the National Water Model. The short-range and medium-range forecasts provide river discharge estimations for the next 10 hours and the next 10 days for more than 2.7 million river segments in the US. This Livefeed layer is used by local communities and emergency operations centers to improve the deployment of people and resources on the ground during an emergency. The National Water Model is also being linked to flood mapping services to better determine the extent of the flooded area and population at risk. The USA Weather Watches and Warnings shows the events, statements, watches, warnings, and advisories from the National Weather Service. The layers are updated with a frequency of 5 minutes. This Livefeed layer shows how inclement weather can affect local communities and economic activities. The Livefeed tools, workflows, and methods can be implemented in a high-frequency and multi-layer item, resulting in a reliable service. We've seen examples of disaster response maps. Now, let's switch gears to talk about hosted views. Views can help us customize our ArcGIS online layers to different users, improving update cycles, user experience, and performance. We can create multiple hosted views for diverse applications, having the advantage of avoiding data duplication. A single feature service can power multiple hosted views. For example, the World Database on Protected Areas from the UN Environment Programme shows the areas in the planet subject to environmental protection rules. There is a hosted view for the complete protected areas dataset. Then we can create additional views by applying feature filters. For example, there is another view showing the areas that are protected by local communities. There is a view showing marine and coastal protected areas, and there is another view for areas with government protection. Each view of the feature service is part of Living Atlas. The World Database on Protected Areas is updated every month by a Livefeed routine. The Livefeed methodology can be used for regular data updates, not only for near real-time natural disaster layers. The NOAA Global Temperature Anomaly dataset in Living Atlas is another layer that uses multiple views. There is a view with the complete historic dataset and another view with the latest monthly results. The view on the left can be used to see how temperature anomalies have changed over time. The view on the right is used to assess the latest values on temperature anomaly around the world. Views are key for Livefeed layers because we avoid data duplication. There is only one feature service that needs to be updated. We can create multiple views with different feature filters and different symbologies. Another key aspect of views and live feeds is that we can set up a target feature service. A target feature service can be overwritten and then swapped with the active feature service. This allows the live feed routine to update the data set without service disruptions on the active service. A live feed layer can be used in any web map, app, or dashboard, just as any other static layer in ArcGIS Online. For example, there is a wildfire layer in Living Atlas. New wildfires are added to the layer when they are reported. Their burned area is also updated during the event, and eventually wildfires are controlled and removed from the layer. Any application using the wildfire live feed layer will show the latest data. You can start using the live feed layers in Living Atlas in your own web maps, apps, and dashboards. For example, we have a recent earthquakes layer from the USGS Prompt Assessment of Global Earthquakes for Response program. We have an active hurricanes layer from the National Hurricane Center and the Joint Typhoon Warning Center. Or we have an Arctic and Antarctic sea ice extent layers from the National Snow and Ice Data Center. So depending on your application, it is likely that there is something in Living Atlas that can add value to your web map. In conclusion, live feeds drive disaster response maps by keeping data up to date using automated workflows and tools. The live feed methodology can be used for both high frequency or routine updates. Finally, any live feed layer can be used as any other static layer in ArcGIS Online, so you can browse and add Living Atlas live feed layers to your own web maps. We appreciate your feedback. Remember to complete the session survey in the link below. Thank you for listening to our presentation. Now, we'll transition to our moderator for the Q&A.
Hello, everyone. My name is Ken Ballin. I'm a project manager on the Living Atlas team, and I'll be moderating this session. We'll be starting the QA now, and it looks like we have some great questions in the window, so please keep them coming in. So let's begin with our first question. And Denise, I think this is a great question for you to start with. Is Living Atlas available to everyone, or do you need a license?
So if it's a premium content within the Living Atlas, yes, you need a subscription to see the content. But if it's a public content, no license needed.
Okay, great. Next question, can I use live feeds in analytical tools? Gonzalo, do you want to take that?
Sure. Yes, you can use live feed layers in analytical tools. You can load them in ArcGIS Pro and use them as any other layer as an input to any geoprocessing tools.
Perfect, thank you. Next question, Paul, I think this would be a great question for you. If you're pulling a Living Atlas service from its host URL and not using a local copy of it, would it still be necessary to run any updates to get the latest data? Wouldn't the service automatically update its data that the host is providing?
Yes, if you're pulling data from an existing service as a client, like a map viewer, then the service will maintain its data and you'll be able to get the latest updates as soon as they're available to it. But if you're talking about creating a live feed service of your own where you're harvesting data from another service, then you need to actually run that feed routine to periodically harvest that data and update your feed or your service in this case. Hopefully that answers the question.
Okay, perfect. Okay, next question. Can you show me how you got to the groups page again? Denise, I think that'd be a perfect question for you to take.
Sure. So I can describe how we get there. If you go to your Living Atlas website and then type live feeds in the search box and search, you will find a lot of Livefeed content. And in one of the contents, you're going to see feature layer by Esri Livefeed 2. And if you click on that Esri Livefeed 2, then you will see 3 icons that shows profile, items, and groups. So you can click on the groups and you can get there. Or we can share the group's link on our chat here, and then you can just bookmark that link on your web browser. Or you can always watch our replays because they're going to post later on. So, yeah.
Great, thank you. Next question, can you use Living Atlas in ArcMap? Who wants to take that question?
I can take it. Yes, you can use Living Atlas layers in ArcMap. There is a section on the portal where you can display the layers. You can search for them when you add data and just use them as any other layer.
Great, thank you. Let's see, we have another question. Do people who want live feeds also want historical trends? Paul, do you want to take that?
Sure. Historical trends are available if you're actually capturing the data over time. So if you're appending to a layer and you're just building it up over time, then you can get that information. As far as do users want that if they have a live feed? Not necessarily, though. I mean, not everyone needs to see the historical information. They may only want to see point in time or up to the minute current information. So it just all depends on what your audience that you're trying to serve and what their needs are.
Okay, thank you. Let's see here. Another question just came in. Can you brief up? That one's been accepted, answered. Okay, how about this? If the data from these layers encroaches one service territory boundary, is it possible to set up alerts or notifications?
From the live feed side, I'll take that, sorry. From the live feed side, not necessarily designed to do that. You're starting getting into the boundaries or fence lines that you might have in GeoEvent, where you can actually have it automatically restrict or act upon a fence and do something, like a notification for you. Although it's not something that is outside of the realm of doing from a live feed, the script would have to actually be designed to accommodate those type of features, but you have the ability, if you so choose, to do it.
Okay, thank you. Let's see, we have another question that just came in. If you want to capture snapshots of live feeds for the purposes of creating static backups in case the live feeds goes down, what would be the best way to do that?
I could take that one. Probably the simplest way would be to actually hit the REST endpoint service and query it for data and then save it as JSON. That gives you, the copy of the data itself. There's also, in many of the live feeds, the data extract has been enabled on them. And so you can actually extract data from that once in a while and be able to pull it locally and keep a copy. Then what you do with that data, if you so choose to put it into your own environment, which is one thing that the original live feeds were built for, was to take that third-party data and bring it into your enterprise and store it into your own enterprise SDE database and then serve it up locally. So you could eliminate all traffic outside of your own organization and have that resource local to your end users. And then you would have a live feed routine that would go out and pull that data from its source and update your local copy, at some set time frame, some 5 minutes, 10 minutes, whatever's appropriate for the data change.
Okay, perfect. Let's see, next question. How do we do a layer swap after you publish a second version of a layer?
I can take that question. So first, you add the relationship of the idle service to the hosted view, and then you can perform a layer swap. both methods can be done using the overwrite script that Paul mentioned during the presentation. I hope that answered the question. I'm not sure if you want to add something, Paul.
No, I think you've pretty well satisfied that one.
All right.
Okay, great. Is it possible for me to create a view layer to share with others in my ArcGIS online org of a living atlas layer to filter for geographic region, for example, to show only wildfires in California, I presume?
I guess I can try and see if I can get that one answered here. You can't create a view of the existing service that we own or that anyone else owns. So you're not able to create a view from another service that a different user owns. But you can create a web map, for instance, that uses that layer, and then you could set a filter on it. And you filter out just for the area that you're interested in by attribute query, but I don't think you can do it by geographic definition query or anything like that. But if you have your own service and you want to create a view that does restrict access to a given location, you can do that from your view.
Okay, thank you. Let's see, we have a password question. What is the suggested way to point to ArcGIS Online password protected, parentheses, Living Atlas Premium Services, live feeds in apps such that Portal Enterprise users don't have to log in? And the person that posted the question is in an enterprise environment.
This is a Living Atlas for Portal or Enterprise question, basically. If that live feed item has been included into the Living Atlas for Enterprise release of your enterprise portal install, then your client should already have access to it and already include a redirection and authentication to it. But they are public, so they shouldn't even require an actual password or token to get to it. So maybe we have to see which feed you're talking about that requires authentication, because this is a very specific portal question in how content is shared with portal and how the portal users can access that content from their portal. So there is authentication that happens at that level that allows the user to use a proxy that gets into that approved item that's in their portal, even though it resides in ArcGIS Online or in Living Atlas environments. Does that help?
I just added a reply with a link with a great resource about different authentication schemes, the ones that Paul is mentioning. So that link is has a lot of descriptions and more detail about how to do all those things.
Right.
Great, thanks, Gonzalo. Okay, next question that just came in: is Python used in any of these Living Atlas?
I'll answer that one. They are used in all of our Living Atlas live feed routines. They all leverage Python to do the work. Most will leverage even the Python API to do a lot of the work. So we use it for managing the data downloads, the data interpretation, parsing. ArcPy is used in a lot of cases to do any of the GIS work that we have to do on that data. And then of course Python API is leveraged to do the updates and overwrites, those kinds of things on the services. So yes, heavily.
Okay, thank you. All right, don't think we got this. How do you do a layer swap after you publish the second version of a layer?
I think Gonzalo just
get that one.
Yep.
Perfect. Okay. Any other questions, folks? Any questions for the panel here?
Can always go in more depth if we need it.
give it a second if any of the attendees have any other questions that we can help answer. Okay, we just got a question here. Let's see. Can you post a link regarding authentication publicly and not in reply so visible, please? Oh, not a question. These are comments. Okay.
Sure, if you can send that copy of that one out, Gonzalo.
Yep.
Yes, I have it here.
Do they ever?
Paul, here's an interesting question, and I know you'll love this question. Do live feeds ever hiccup?
Well, of course, it's the internet. Yeah, there are cases where you're running the feeds. These things run all the time, so you'll have some feeds that run every 5 minutes, some every 2 minutes. It all depends on the data refresh interval, and eventually you're going to run into hiccups on there. It could be unable to get to the source data. It could be a failure to actually update or overwrite the service. These things happen over time. We try to mitigate them as much as we can, but things do happen and they do hiccup. But in the last, I think 6 or 8 months now, we have addressed every catastrophic issue we could run into in the live feed environment and ArcGIS Online, and fixed a lot of things that were causing us problems. On the back end, we've done a lot of work on that, worked closely with our online team, and we've successfully fixed all these issues that would be causing end users trouble if they tried to do this stuff on their own. So I think we've come a long way with that, and the feeds are pretty much self-repairing. So if they have a failure, an issue accessing the service or trouble updating content, then the next run cycle that happens will correct the issue. So they're pretty autonomous at this point, and they run day in, day out without causing any major problems. Access issues do still happen. If there was a failure at some point that might disrupt the end user, you might see some failures, but for the most part, they're able to self-heal and continue motoring on. So
I would like to add something to there. We recently released live feed status page. So in case if any of these hiccups happens, you can always check from that live feed status page in order to see the current status for each of our live feeds. So I'm going to share the link there here in the chat too. I'm going to reply that thread with this link.
Okay, thanks, Denise. It looks like we take one more question. Looks like Gonzalo, can you go into more detail about the create view that Gonzalo spoke about in the questions? I have done it, but want to understand exactly what it is doing. Maybe Gonzalo, if you can just give a minute or two tip or some additional information.
Yes. So what it's doing, first you have to log into your ArcGIS account. And then in the overview page of the feature service that you want to create a hosted view, there is a button on the right and says create view layer. When you do create view layer, it creates a new item. So you have a new item ID, and that item is referenced to the hosted feature service. For example, if you have an item with multiple layers, each layer is referencing the same table in the database or the same feature service. So when we update the hosted feature service, those changes are reflected also in the hosted view. There are a few advantages of using hosted views, as we discussed in the presentation, that we can change the symbology, we can tailor it to different audiences, and those changes or those properties stay within the view. So when we overwrite the hosted feature service, we don't lose those changes. So in summary, yes, we create a representation of the feature service that links the same tables or the same layers to the same database behind the scenes.
Okay, perfect. Thanks, Gonzalo. Well, we're just about out of time here, and I know there's a few questions that we were unable to get to. So if you'd still like to get your questions answered, you can reach out to any of the speakers or additional experts that are listed below and clicking on their tiles, you'll see the names of the additional experts there as well. Thank you for attending this session and have a great user conference.
Thank you all.
Thank you. Thank you.
Thank you.
Thank you.